Okay, so I realized I didn't really do a great job of explaining what the algorithm is here. Well, first of all, what is the notation? I used it a couple of times, but let me use it. So x inverse is the right x to the minus 1, and that means the inverse of the matrix X. And the algorithm is pretty much this. 1. You write an augmented matrix with the matrix X to the left of the bar and the identity matrix to the right. 2. You reduce it so that 3, you end up with the identity matrix on the left and the inverse on the right. So let's do two 3 by 3 examples of this. So let's compute x inverse, where x is equal to 1, 0, -1, -2, 1, 1, and -3, 1, 3. So the first step we do is just write the augmented matrix 1, 0, and -1, -2, 1, 1, -3, 1, 3, and over here we write the 3 by 3 identity matrix. Now, I've already got a 1 in the upper left-hand corner, so what I'm going to do then is get rid of the -2 here and the -3 here. I'll take 2 times row 1 and add it to row 2, and I'll take 3 times row 1 and add it to row 3, and what that will leave me with is, on the left, the top stays is 1, 0, -1. 1 times 2 plus -2 is 0. 0 times 2 is 0 plus 1 is 1. And 2 times -1 is -2 plus 1 gives me also -1. Okay. 3 times 1 minus 3 is 0. 3 times 0 plus 1 is 1. And 3 times -1 plus 3 is equal to 0. What happens over here? The top row stays the same. The operations are actually pretty easy. I'll let you check that you get 2, 1, 0 and 3, 0, 1. I've already got a 1 here, so I just want to get a 0. I've got a 0 up here, so I just want to get a 0 down here. So all I'm going to do is take negative row 2 and add that to row 3. It's supposed to be a 2 right there. Because -1 plus 1 gives me 0, so this leaves me with 1, 0, -1, 0, 1, -1, and 0, 0, -1. -1 is 1 plus 0 gives me 1. And this gives me 1, 0, 0 at top, 2, 1, 0 here. And then the negative row 2 is -2 plus 3 gives me 1. -1 plus 0 gives me -1, and 0 plus 1 just gives me 0. And then finally, I want to get rid of these 1s up here, so I just am going to add row 3 to row 1, and row 3 to row 2, because, well, -1 plus 1 gives me 0. So on the left, I end up with the identity matrix, which is what I was looking for. This is reduced. On the right, I'm just adding row 3 to row 1, so I get 2, -1, 1. Adding row 3 to row 2, I get 3, 0, 1, and my last row is 1, -1, 1. And I encourage you to go ahead and check that this works out. So that will be your exercise. In any case, x inverse is 2, -1, 1, 3, 0, 1, 1, negative 1, 1. I am 90% sure that that is right. Looks pretty good to me. Okay, let's do one more example of this sort of thing with a 3 by 3 matrix. Okay. Okay, so let's do another example of this. We are going to take the matrix, what is it? We will start with the matrix X equal to 4, 2, 1, 3, 2, 4, and 1, 1, 3. And let's find the inverse, X inverse. Okay. Well, the way we start this off is we will draw the augmented matrix 4, 2, 1, 1, 0, 0, 3, 2, 4, 0, 1, 0, that's a 0, and 1, 1, 3, 0, 0, 1. Now, first we would like to get a 1 up here, and the obvious thing to do, I think, here is to swap rows 1 and 3. So we'll just do that. I got 1, 1, 3, 0, 0, 1, 3, 2, 4, 0, 1, 0, and then 4, 2, 1, 1, 0, 0. Now we will take, we want to get rid of this 3 here, so negative 3 row 1 plus row 2, we'll get rid of that 3. We want to get rid of the 4, so negative 4 times row 1 plus row 3 will give us that. And what we're left with then is 1, 1, 3, 1, 0, 0, 1 on top. That becomes 0, 1 times negative 3 plus 2 is negative 1. And 3 times negative 3 plus 4 is equal to negative 5. Then I want to get rid of this 4 here. I got a 0 here. Negative 4 times 2 negative 4 times 1 is negative 4 plus 2 is negative 2. And negative 4 times 3 is negative 12 plus 1 is negative 11. Over here we get 0, 1, negative 3, and 1, 0, negative 4. Now I'm going to just multiply row 2 by negative 1 to change this minus 1 into a positive. I'll just write that down here briefly. So I get 1, 1, 3, 0, 0, 1. I get 0, 1, 5, and 0, negative 1, 3. Over here I get 0, negative 2, negative 11, and 1, 0, negative 4. Now I want to get a 0 up here, so I take negative row 2, and I'll add that to row 1. Now I'm going to want to get a 0 down here, so I'll take 2 row 2 and add that to row 3. And what I end up with then is negative 1 plus 1 is 0. Negative 5 plus 3 is negative 2. And over here I get 0 plus 0 is 0. Negative 1 times negative 1 is 1 plus 0 gives me 1. And 3 times negative 1 is negative 3 plus 1 gives me negative 2. Okay. The middle stays at 0, 1, 5, and 0, negative 1, 3. And the bottom becomes 0, 2 plus negative 2 is 0. And 5 times 2 is 10 plus negative 11 is equal to negative 1. 0 times 2 is 0 plus 1 is 1. Negative 1 times 2 plus 0 is negative 2. And 3 times 2 is 6 minus 4 is equal to 2. Now we're going to take the negative of the bottom row because I want a 1 here. And I got 1, 0, negative 2, 0, 1, negative 2 as expected, 0, 1, 5, 0, negative 1, 3, and 0, 0, negative 1, 1, negative 2, 2. And I want to get rid of this 5 here and this negative 2 upstairs. So I'll take 2, this was supposed to become a plus, a minus, a plus, and a minus. Excuse me, I just wrote the same thing down over here, so that should be a plus, minus, plus, minus. Okay, so I'm going to take 2 row 3 and add that to row 1 to get rid of this negative 2. I'll take a negative 5 row 3 and add that to row 2 to get rid of this 5. So on the left, this will immediately give us the identity matrix. It reduces it. Over here, 0 plus 2 times negative 1 is negative 2. 1 plus 2 times 2 is 5. And negative 2 times 2 is negative 4. Minus 2 is negative 6. Okay. Negative 1 times negative 5 plus 0 is 5. Negative 5 times 2 is negative 10. Minus 1 is negative 11. And negative 5 times negative 2 is 10 plus 3 gives me 13. And then down here it just stays negative 1, 2, 2, negative 2. Okay, so if you give me just 2 seconds to check my work over on the side of I have math software which lets me check this sort of thing. Yes, that is indeed correct. But the best way to check this, how can I check that my work is right without a calculator? So let me get back over here. So this right here, this is x inverse, and to check, all I have to do is check that x times x inverse, or x inverse times x, is equal to the 3 by 3 identity matrix. So go ahead and do that.